All right, today's reading assignment is density. After this reading assignment, you should be able to define density, use physical measurements to calculate density, use density values to calculate mass or volume. How do logs stay afloat in water? After trees are cut, logging companies often move these materials down a river to a sawmill where they can be shaped into building materials or other products. The logs float on the water because they are less dense than the water they are in. Knowledge of density is important in the characterization and separation of materials. Information about density allows us to make predictions about the behavior of matter. Density. A golf ball and a table tennis ball are about the same size. However, the golf ball is much heavier than the table tennis ball. Now imagine a similar sized ball made out of lead. That would be very heavy indeed. What are we comparing? By comparing the mass of an object relative to its size, we are studying a property called density. Density is the ratio of the mass of an object to its volume. The formula for density is density equals mass divided by volume. Density is an intensive property, meaning that it does not depend on the amount of material present in the sample. Water has a density of 1 gram per milliliter. That density is the same whether you would have a small glass of water or a swimming pool full of water. Density is a property that is constant for the particular identity of the matter being studied. The standard international units of density are kilograms per cubic meter. Since the kilogram and the the meter are the standard international units for mass and length respectively. In everyday usage in a laboratory, this unit is awkwardly large. Most solids and liquids have densities that are conveniently expressed in grams per cubic centimeter. Since a cubic centimeter is equal to a milliliter, density units can be expressed in grams per milliliter. Gases are much less dense than solids and liquids, so their densities are often reported in grams per liter. Densities of some common substances at 20 degrees Celsius are listed in Table 1.1. Since most materials expand as temperature increases, the density of a substance is temperature dependent and usually decreases as temperature increases. You know that ice floats in water and can be seen from the table that ice is less dense. Alternatively, corn syrup, being denser, would sink if placed into water.